Hello everyone. We have already done with plate tectonics, continental drift theory, sea floor spreading theory, and I think you are much more comfortable with these theories. We now know why there are basic reasons for the fold mountains, basic reasons for the kind of mountains which are parallel to the continents. We know the basic reason for the oceanic trenches, for the volcanoes and for the earthquakes. Now taking our lecture further, we'll start with the topic today known as Earth's movements. Or geomorphic process. Now why is this topic important? Now see, these Earth movements, what are the Earth's movements and how do they affect, and why are we studying this topic? Basically, we do not live in the Earth is not stable. The Earth is constantly undergoing some kind of a changes. In fact, some of you students may be living in the hilly regions, some of you may be living in the plain regions, some of you may be in the coastal regions. Even the kind of a soil you must be experiencing near your home will be different depending upon area which you are living, upon the climate which is there. Now we also know that the Earth is not flat enough. The Earth is not at all a flat and a boring place. There are very, very beautiful places. For example, some mountain regions, valleys, beautiful valleys are there. Some dangerous mountain peaks are there. Some very flat agricultural land is there. Depending on the topography present in that area, depending upon the geomorphic process operating in that area, and therefore we are studying this topic. For example, even if we take India also we see that there are different kind of land structures. We have Leh Ladakh region or the Leh Ladakh plateau region at a certain height. Then we have the three ranges of the Himalayas. We have the Great Plains of India, which have been deposited by the sediments which have been brought down by the rivers which operated in India for a long period of time. We have the plateau region of India. We have the coastal plain. So here we have Leh Ladakh plateau, or we can say the Tibetan plateau region. We have the Himalayan region. We have the plains of India. We have the Indian plateau, which is known as Deccan Plateau or the Peninsular Plateau. We have the coastal plain of India. Give you an example. Leh Ladakh region of India, Srinagar, other hill stations, for example, Dehradun, Delhi, Jaipur, Allahabad, Varanasi, Nagpur, Bangalore, coastal plain, take an example, Chennai. So we have different kind of areas, different kind of cities. That's why the reason for this diagram is to show that the Earth is not at all a flat surface. There are too many different kind of features which are there present on the Earth. Now why this features is not there? Because the Earth itself is a dynamic process. The Earth's crust is dynamic, which is being subjected to the continuous changes which occur on the Earth. The dynamic Earth is constantly undergoing some changes due to different forces which operate on the Earth. There are some forces which build the mountains, while there are some forces which bring down the mountains to the sea level. That is, there are some forces which will result into the upliftment of a land to form a mountain. The other forces will reduce this height of a mountain and try to bring it down to the sea level. So there are some land building forces, while there are some land eroding forces. So based on this, some of the forces are there which originate from inside the Earth. What we have already done, two forces. For example, we have seen in the animation in the last part, there are two forces which originate from inside the Earth. One is volcano. What is volcano? Volcano is the outpouring of a molten rock along with hot molten rock That is a river of fire, for in a simple English term, a river of fire. So we have a volcano which is operating, which comes from inside the earth. Then we have earthquake which originates from inside the earth. The point where the earthquake originates is different from where we live. Focus versus epicenter. So we have earthquake, we have volcano which originate from inside the earth. Now for example, mountains. How are the mountains built? Is it like we play with the clay, that there is a flat surface and then somebody puts a mountain? It's not like that. Something is building the mountain, some forces are operating which is folding the earth, which is crushing the earth to form a mountain. So thus the mountains are also built in this way. As a result, there are some forces, while there are some forces which destroy the mountain, which break away the rock. For example, if the person is staying in a hilly region, if the person is going to a hilly region, you must have commonly experienced landslides. When do these landslides occur? Mostly during the heavy rainfall. So there is the water comes, it breaks the rocks, it takes away the land, it removes the rocks and it lowers the height of a mountain. Example, landslide. River, when it flows through an area, it takes away the mud. Over the period of time, it will erode, it will keep on eroding the earth and it will try to level down the earth. Glacier, when it comes out, it takes away everything which comes in its path. So these are some kind of forces which operate from outside the earth. There are some kind of forces which operate from inside the earth. And there is a constant struggle, or we can say there is a constant operation of these forces, and based on which forces dominate in what region, based on this we have different kind of landforms on the earth. So what are the different kind of the earth's movement, or what are the different kind of geomorphic processes? So what are the first geomorphic processes? Geomorphic processes are the forces which operate on the earth, both from inside as well as from the outside of the earth. So based on this, we basically divide the earth's movement into two types of forces: endogenetic movements and exogenetic movements. So we have endogenetic force and exogenetic force. Now this exogenetic as well as endogenetic. What is the difference between the exogenetic and endogenetic? The name itself says endo means inside and genesis means origin. So the one which originate from inside the earth are endogenetic forces, while the forces which originate, exo means outside and genesis means origin, the forces which originate from outside the earth are known as exogenetic process. So we have the two kinds of processes known as endogenetic process, the one which arise from inside the earth. We have exogenetic process, one which arise from outside the earth. So based on this, we have the two kinds of force which are operating. Endogenetic force, the force endogenetic force operates from inside the earth. The exogenetic force operates from outside the earth. The exogenetic force we will write in detail later on. The endogenetic forces are further divided into, or we can say the endogenetic movements, you can use any word. The endogenetic movements are divided into diastrophic movements and the other division is sudden movements. I will first deal only with the movements. So they are divided into two types: diastrophic forces or diastrophic movements and sudden movements. Now, the diastrophic force are, what does the word diastrophism means? Diastrophic means extremely slow force or extremely slow movements. And on other hand, the sudden forces means which can be felt in our own lifetime. For example, yesterday we did, in last lecture we did that there is a plate in the theory of the plate tectonics. We know that the earth, the Indian plate is still going below the Eurasian plate. Due to this, there is increase in the height of the Himalayas. Now we also know that how did Himalaya form? Himalayas formed due to the collision of Indian plate with the Eurasian plate. Now with the collision of Indian plate and the Eurasian plate, the sediments were folded to give rise to the mountain ranges. As a result of this, there was a formation of Himalayas. Now, how did it occur? Did it occur in a night? Is there somewhere, have you experienced something that you are sleeping and suddenly you get up on the top of a mountain? No. This mountain building forces, the creation of a land, creation of a mountains, takes lot of time. It does not happen that I am taking a lecture here in the studio, and when I come out of the studio, I am at the top of a mountain rather than on the somewhere original place. If it's on the top of a mountain, it will remain on the top of a mountain. If it's on the plain region, it will remain on the plain region, at least till my lecture gets over. It is going to remain for millions of years that way. There will be very, very small changes, very, very slow changes which cannot be detected by human beings. Such kind of movements or such kind of forces which are extremely slow or very slow movements are known as a diastrophic movements. On other hand, it's a common experience that we suddenly feel the shaking of the earth. There are many instances where you are sitting in the house, you are doing some work and you suddenly feel the shaking up of the earth. That is earthquake. Earthquake occurs in a lifetime. Earthquake occurs in seconds, and because we do not have time to react, it causes much of a destruction and damage. So such kind of a force which occurs suddenly, which can be experienced by us, are known as sudden movements. The best example of a sudden movements are volcanoes and earthquakes. On other hand, the diastrophic forces are very slow movements, while the sudden movements are very fast, which can be limited, which can be experienced in a lifetime. These are examples are volcanoes and earthquakes. So repeating once more, the earth movements are divided into two types. These geomorphic forces, or the forces which affect the earth, are divided into two types: endogenetic and exogenetic. The endogenetic force are the forces which have origin inside the earth, while the exogenetic are the originating from outside the earth, or we can say originating from the earth's atmosphere. Now the endogenetic forces are further divided into diastrophic movements, which are very slow movements, and sudden movements, for example earthquakes and volcanoes. Now what does this endogenetic movements mean? This endogenetic movements, for example diastrophic movements and sudden movements, build some kind of a landforms on the surface of the earth. For example, yesterday in previous lectures also we have done till now that if there is a magma is coming out of volcano, it becomes a lava, and then it is getting solidified, deposited to form an igneous landform. What will be the nature of the igneous landform? It will depend on the kind of an area. If there is a fissure kind of a volcanic eruption that is similar to the sea floor spreading, the kind of a volcanic eruption which occurs in the sea floor spreading region, it will build a different kind of a landform, but obviously it will build a landform. On other hand, if the volcanic eruption is at the plate boundary where there is a convergence of the plate going down of the plate, it will build volcanic mountains. So depending on this, it will build a landform. So that means a new Earth's crust is being created by the endogenetic movements. Volcanoes, earthquakes, they destroy the building, but they will modify the landform. For example, sometimes they will create a crack inside the earth. Diastrophic movements, very, very slow movements, which are related to the plate tectonics. We will study those in detail. They will also build some kind of a landforms. They will build mountains. The mountains are caused due to coming together of two plates and the folding of the sediments from these two plates, resulting into increase in the height of a mountain, formation of a mountains. So these endogenetic movements are land building movements, or you should remember these are known as these are known as land building forces, which help in the creation of landforms. Example, volcanoes will form new volcanic eruption inside the ocean floor, forms new crust. Volcanic mountains, volcanic plateaus. Yesterday in the last lecture we did that when Indian plate was moving over a Reunion hotspot, Deccan lava plateau was formed. So endogenetic movements, volcanoes, any kind of a fold mountains, this will help into building up landforms. So the endogenetic movements forces, you remember, are land building forces. On other hand, heavy rainfall washes away the mud. If there is a flood, everything is destroyed, carried by the water, deposited water, river water will go into and mix with the ocean or go into the sea. So every sediment is carried into the sea. Glacier comes, takes away everything, mixes with maybe ocean in the higher latitudes, or it's converted into river, for example, Gangotri Glacier, etc. So this air, it will take away mud, it will take away small kind of sand from one area, deposit it in some other area. So these forces, exogenetic movements, are land destroying forces. They will wear down, they will reduce the height of a mountain over a period of time. Once upon a time, Aravalli mountains in India were as high as Himalayas. They are now today just in the form of a small hills. The exogenetic forces will have same effect on the landforms as they have the effect on our houses. If the house is very old, over the period of time, due to exposure to rainfall, due to exposure to climate, due to exposure to high heat, the walls started breaking down. And if the house is not repaired, if the house is not maintained, the house completely gets destroyed. So same analogy you apply to the mountains also, to any kind of a landform. The landforms are destroyed, their height is reduced by the exogenetic forces. So therefore they are, we can say the exogenetic forces wear down the surface of the earth. They wear down the surface of the earth through the process of, there are two processes which we will study in detail later on. There are through the process of, through erosion and weathering. So what are the exogenetic forces? One is erosion and the other one is weathering, WEA. THERING, that is weathering, that is the removal of the rock surfaces, and the other are erosion. So there are two kind of exogenetic forces. Because they reduce the height of a land, they wear away the land forces, therefore they are known as the forces of gradation, or the forces of wearing and tearing of the rocks. So these are the basic forces. Now coming back to the endogenetic forces, these endogenetic forces are divided into diastrophic forces and that is very slow forces, and the sudden movements. We already have done the sudden movements are of two types, volcanoes and earthquakes, while the diastrophic movements are divided into, again can be further divided into epirogenetic movements and orogenetic movements. Epirogenetic movements and the orogenetic movements. Now, what do you mean by epirogenetic movements? Epirogenetic movements. This epirogenetic means continent making, while orogenetic means mountain building forces. So there are some forces which affect the entire landform, that is the continents, while there are some forces which affect only a localized landform, turning it into the mountain or making it a mountain. So based on this, the diastrophic movements are either further classified as epirogenetic movements and orogenetic movements. Epirogenetic movements are the movements which affect a larger landmass. For example, if this is the entire continent, and if there is a presence of a mountain here in the continent, on the continent, the epirogenetic movement will affect this entire landmass. It will either bring this landmass below the sea level, that is subsidence, or it will either uplift this landmass above the sea level. So this process, obviously, again you remember, takes millions of years, extremely slow, does not affect our life cycle directly, but the earth will keep on changing. So that is, even the continents are still drifting, but we cannot feel the drifting of the continents. That is an example of an epirogenetic movement. It is not as if that if you are South America and North America are drifting away from Europe and Asia, Europe and Africa, and it's coming towards Asia, so you can stand on the North America and come to Asia. No, the process is very, very slow. It is taking millions of years. But this epirogenetic movements means it will affect this entire landmass, a larger landmass. It will either uplift the landmass, or it will either bring the landmass below the sea level. That is upliftment and subsidence. While orogenetic movement means it will affect this mountain. That is, for example, if this is a mountain, increase in the height of a mountain, decrease in the height of a mountain, or reduction or how this mountain has been created. That is, these are mountain building forces. Now, because our course is limited to GS, general studies, we will focus mostly on the orogenetic movement and not on the epirogenetic movements, because orogenetic movements are the movements which result into mountain building. So this, And again, I won't go too much into classification because they can be further classified as upliftment and subsidence, orogenetic as tensional forces, compressional forces. Then they can be further classified as reverse tensional, compressional, folding, faulting. But I'll give you a simple definition, only simple classification for you to understand. So the epirogenetic movement is related to, you can in fact take it down, epirogenetic movement is related to upliftment and subsidence of landmass, that is continents, while orogenetic movements or orogenetic forces are mountain building forces. These are the mountain building forces. These orogenetic movements can be further classified into, we will take a very simple classification into compressional and tensional forces, or we will take again a simple classification into faulting and folding. So these orogenetic movements are further classified into folding of a landmass and faulting of a landmass. So here, revising again, the earth movement are classified into, these earth movements are the movements which affect the entire landform. These are also known as geomorphic process because the earth's crust is not stable, it is a dynamic. It is being continuously subjected to external as well as internal process, and based on this we divide the earth's movement into endogenetic forces or endogenetic movements and exogenetic forces or exogenetic movements. The endogenetic forces, as the name suggests, originate from inside the earth. They help in building continents, they help in building land masses, they help in building mountains, different kind of mountains, and they are known as land building forces. While the exogenetic movements originate from outside the earth. For example, weathering and erosion are the best examples of exogenetic forces. What these do, they reduce the height of a landmass, they try to bring down the uplifted or landmass down to the sea level. And these are known as the forces of gradation. The endogenetic forces are further divided into diastrophic movements, which are very, very slow movements, cannot be felt in a lifetime, and sudden movements such as volcanoes and earthquakes. The diastrophic movements are further classified as epirogenetic movements, that is continent or landmass, origination of a landmass. This reduce into upliftment or subsidence of a landmass, and orogenetic means related to mountain building. That is why orogenetic. These are known as orogenetic movements which help in these are mountain building forces. The orogenetic movements are further classified into two major movements, that is folding and faulting. Now coming to exogenetic movements. Exogenetic movements are further classified as weathering and erosion. Now our further lectures will be based on this application part of geomorphology. What do you mean by folding? What is faulting? What kind of a different mountains are there? For example, what are the fold mountains? What are the block mountains formed due to faulting. What is anticline? What is a syncline? Then what do you mean by weathering? Weathering of different forms. For example, weathering can be further classified into physical weathering, chemical weathering, and biological weathering. While erosion is by different agents such as wind erosion, water erosion, glacier erosion. So these are the different agents of erosion. So based on this we have different kind of earth movements. So we will be studying now what are the different kind of movements, what are the different kind of folds, how does it, why are we studying, or what is the practical application of fold, what is the practical application of faulting, and then different kind of weathering processes and different kind of landforms which have been specified in your syllabus. That is the origin of different kind of landforms or the changes in the landform. So how do these changes in the landform occur? Changes in this landforms occur for a very slow period or for sudden period. Sudden period has been specifically mentioned in your syllabus, that is volcanoes have been given, earthquakes have been given, which will be studied, as well as the changes in the landforms due to mountain building, due to that is how the landform is elevated, and then changes in the again landform due to different agents of erosion and different agents of weathering. One more agent of erosion which is becoming, or one more agent of erosion over the period of time has now become human being. Human being has accelerated the process of erosion, resulting into imbalance into the on our earth, whether it is in the atmosphere or whether it is on the land. So we are polluting the land, we are eroding it at a very, very faster rate rather than the replacement what nature can provide a replacement level. Rather than the rate of replacement, we are eroding. So these are the applied parts of our next part of our geomorphology, that is the earth movement, and then studying each and every earth movement in detail. So till this I think you are clear, that is what are the different kind of forces and this. Now further again, this endogenetic forces are further divided into epirogenetic and orogenetic. Epirogenetic is upliftment of a landform, that is taking the landform up, and subsidence of a landform, while the orogenetic movements are folding and faulting. Now, what are the folds? Now suppose this is the crust of the earth. We know that now after studying the interior of the earth, we know that the crust on which we are living is an extremely thin as compared to the entire earth. So this crust of the earth, if it is folded, if it is compressed, if it is compressing here, I am compressing the crust of the earth, it is being folded. And so, imagine that this my two fingers are forces which operate from inside the earth, that is these are endogenetic forces, and they are resulting into creation of this kind of bends on the surface of the earth. So the wave-like bends which are created on the earth's surface are known as folds. So our topic there is folds. What are folds? Folds are wave-like bends. Folds are wave-like bends which are formed on the Earth's surface on Earth's surface due to endogenetic forces operating from inside the Earth. That is again this due to endogenetic wave-like bend formed on this flat. This was a flat surface of the Earth. Endogenetic forces are operating, and over the period of time, this crust of the Earth is being folded. Now see, this crust of the Earth is being folded into two parts. It results into formation of some kind of a mountain-like feature, while on the other hand it is also resulting into the formation of some kind of a valley-like feature. So the folds result into the formation of two features which are known as this is a middle axis. The Earth's surface is folded into two type of feature. The up-folded, that is this upper part, this up-folded feature is known as anticline, while the down-folded valley-like or depression-like feature is known as syncline. So it results into the formation of anticline and it results into the formation of syncline. So what is an anticline? Anticline is up-folded rock structure. Can take what is an anticline? Anticline is an up-folded rock strata. The up-folded rock strata is known as anticline. Strata is surface, while the down-folded trough-like feature is known as syncline. So we have formation of an anticline, that is up-folded rock strata, and syncline, that is an down-folded. How it is formed? It is formed due to, if this is an entire rock strata, it is formed due to the compressive forces which operate on this rock strata. It result into folding up of this rock strata into an anticline and syncline. Due to the different kind of an compressive forces operating on the earth. The folds are further divided on based on the nature of what are the kind of the folds. The folds are further divided into different types. So what are the folds? Before I go to the next topic, are wave-like bends formed on the earth due to which movements? Due to the endogenetic movements. How are this? Mostly due to the compression. That is, too much compression results into folding up of the rock structure. What is a compression? Which movement will result into compression? Where will be the compression? From the last lecture, will it be at the divergent plate boundary or at the convergent plate boundary? It will be at convergent plate boundary. That when the two forces will come, their folding will occur, resulting into formation of an anticline, that is the up-folded rock strata, or a syncline, that is a down-folded rock structure. It will result into formation of an anticline and syncline. The folds are further divided into, these folds are further divided into the folds are further divided into symmetrical folds, asymmetrical folds, we are further divided into symmetrical folds, asymmetrical folds, monoclinal folds, isoclinal folds, overturned folds, and overturned folds. Now these are the different types of folds: symmetrical folds, asymmetrical folds, monoclinal folds, isoclinal, recumbent and overturned fold. Just to have a basic idea, because the questions here, they are not expected from this because it is out of the syllabus of GS. But what do you mean? What will be the symmetrical fold? The symmetrical fold is an area, is a fold in which both the limbs of the fold are inclined at an same angle. For example, if I am folding this, now it will be an example of a symmetrical fold. Both the limbs, what are the limbs? This is one limb, this is the other limb. They both are inclined at a same angle. What will be the asymmetrical fold? If one limb of a fold is inclined at a different angle compared to the other limb, then it is an example of an asymmetrical fold. Monoclinal fold is a fold in which one limb is inclined at a regular slope while the other limb is inclined steeply. Isoclinal fold is a fold in which both the limbs are inclined steeply, they have become parallel to each other. Recumbent fold is a fold when both the limbs become parallel as well as horizontal. And overturned fold is a fold in which one limb, due to extensive compression, rides on the other limb. And lastly, the last concept is the concept of nappe. Now, we will draw a diagram again here. What is a symmetrical fold? Symmetrical fold if this area is folded, symmetrical fold is a fold in which both the limbs of a fold are inclined at same angle. Asymmetrical fold will be a fold in which one of the limb is inclined at a different angle compared to the other limb. Consider this diagram itself. In the diagram in the part 1, both the limbs, these two are the limbs of a fold, they are all inclined, they are both inclined at a same angle. So this is a symmetrical fold. In the second, inclination of these two is different. So it becomes an example of a monoclinal fold. It becomes an example of a asymmetrical fold. See, in the real life, there cannot be a proper example exactly of a symmetrical fold. It is a theoretical concept because folding depends on many factors. It depends on what will be the kind of a fold, will depend first on the force which is acting. For symmetrical force, the force has to be balanced on both the sides. It cannot be possible. Maybe on one side, one plate is putting a greater force than the other plate. Second, it will also depend on the kind of a rocks. For example, chalk is also kind of a rock. The chalk which you used to write on the blackboard is also a kind of a rock. On the other hand, granite is also kind of a rock. The area where there are weak rocks such as chalk, limestone, the area will be subjected to different force. On the other hand, the resistance to the force by strong rocks, for example granite or the rocks containing iron elements, they will be having greater resistance. So it will depend on different kind of forces. Different kind of forces, resistance of the rocks, etc. That what will be the kind of the folds. So what you have to remember is, generally in real life, we do not have a perfect example of a symmetrical force. So the symmetrical fold is a fold in which both the limbs of fold are inclined at same angle. Asymmetrical fold is a fold where there is irregular inclination of the limbs. Monoclinal fold is a fold in which one limb inclines moderately while the other limb inclines steeply. Isoclinal folds are the folds are the folds in which both the limbs become parallel but they do not become horizontal to the ground surface. Now, I will draw a diagram after you know the definition, so that you will understand that diagram better. Symmetrical fold, not possible because, as I told you, forces may be different. Asymmetric folds will be possible. Now, this asymmetrical fold is also an example of a monoclinal fold, because you see here one limb of a fold is inclined at a steep angle to the ground, while the other limb is inclined moderately to the ground surface. If I further compress this from both the side, if there is further force from both the side, then they will be further compressed, and maybe the folding will occur such that both these limbs of the fold, that is both these limbs of the fold, they become parallel to each other. Such kind of a fold is known as an isoclinal fold. Further compressive forces, maybe from one side, from this side the compressive force is strong enough, this will be compressed in such a way that both the limbs become parallel to each other, and also they become parallel to the or horizontal to the ground surface. That is the axis of a fold. The central part of a fold becomes parallel to the ground surface or becomes horizontal. So it will be an example of an recumbent fold. First, take what is an isoclinal fold. Strong compressive forces make both the limbs parallel to each other, but not horizontal to ground. When the limb become parallel as well as horizontal, when the limbs become parallel as well as horizontal to the ground surface. What do you mean by this is a ground surface? So they will become parallel to each other. Both the limbs of the fold will become parallel to each other, as well as they will become horizontal to the ground surface, which this axis, the central axis of the fold, will become horizontal to the ground surface. Is recumbent fold. Now, overturned fold. See, the name itself is overturned. Now, the folding is occurring. Folding results into extreme folding of this. It is becoming parallel, that is isoclinal. It is further compression is making this fold parallel to the ground surface as well. That is becoming an recumbent fold. Now, if there is a further compression occurring from only this part, and this part is remaining steady, that is my finger which is moving here, this is remaining steady, while from my left hand side, if I am applying further force, it will result into this limb being thrust upon or being put upon this, the lower limb below. Such kind of a fold in which one limb of a fold is being thrust upon the other limb, that is the downward limb, is known as an overturned fold. It is a kind of a fold in which one limb is thrust upon other limb due to extreme compression. Due to extreme compression. So these are the types of the fold. Symmetrical fold in with both the limbs, the fold are inclined at the same angle. Asymmetrical fold when there is an irregular inclination of a limbs. Monoclinal fold in which one limb is inclined moderately while the other limb is inclined steeply. Isoclinal fold in which both the limbs become parallel to each other, but they do not become horizontal to the ground surface. Recumbent fold in which both the limbs become parallel to each other as well as horizontal to the ground surface. If we try to show it in the diagram, so this first part will be an example of an symmetrical fold, because if both the limbs are inclined at regular angles. The second is a symmetrical fold, that is irregular inclination of the limb. Third, in which one limb is inclined moderately while the other limb is inclined steeply at around right angles. So it is an example of an monoclinal fold. Fourth, further compressive forces results into both the limb becoming parallel as well as horizontal. Fifth is an example of an recumbent fold, that is both the limbs become parallel as well as horizontal to the ground surface. यहाँ पे in fourth, that is in the isoclinal fold, the limbs do not become parallel, do not become horizontal to the ground surface. If I keep on further compressing from here, it will result into these limbs being thrust on each other. So it is an example of an overturned fold, because the upper part of the limb is thrust upon the lower part of the limb. So overturned fold. Now in this overturned fold, if there is a further compressive force, if the force of a compression becomes further, For example, this is an overturned fold in which one limb is thrust upon the other limb. If there is a further compressive force which is acting from this side, it will result into maybe the elastic limit of this central part or this axis. This central axis will break, because if I keep on bending it, it will bend only to a certain moment, and then further afterwards, when it cannot break, it cannot bend further, it will break. What is breaking? It is the maximum elastic limit. Till the time the maximum elasticity limit of a rock is reached, it will keep on bending. But if once the maximum elasticity limit of a rock is broken, the fold gets broken. And further, then this upper limb will be subjected into different direction. Where the maximum where exactly will it break? It will break at a point where there is a bending, that is at this axis. If I further keep on bending this, then it will break here, because the maximum stress is occurring in this region. It will break at the axis of a bending. Such kind of a broken fold is known as nappe. So lastly, what is a nappe? See, extreme compressive force will result into formation first of a monoclinal fold, then isoclinal fold, then recumbent fold, then overturned fold. If there is a further compressive force, till afterwards this elastic limit will break, and it will break somewhere here, resulting into formation. This upper part of the limb will be broken, it will break at this point. With such a broken limb is known as nappe. So you can take the definition of a nappe, that is the further complex folding mechanism, intense and complex folding mechanism, breaks the limb, breaks the elasticity of the rocks, as a result, the limbs are broken. At such a broken limb, is known as nappe. Is known as nappe. So where will it break? See in this diagram, this is an example and overturn. This is the this will be the chronological sequence of a fold. Isoclinal fold, recumbent fold, then overturned fold. If further there is a more compression of this overturned fold, the limb of a fold will break somewhere at this axis, because this is where the maximum bending has taken place, and such a broken fold is known as nappe. So what is a nappe? Due to extreme bending, is due to extreme compression, extreme bending, the limb of a fold is broken at an axis. Such a broken fold is known as nappe. Now coming to real life, most of the mountain systems in the world will have what kind of a fold? Symmetrical or asymmetrical folds? They will have asymmetrical folds because of the bending. Example, when we draw Himalayas, we see the structure of the Himalayas is not symmetrical, it is asymmetrical. It is folded more from the Indian side because push is more from the Indian side. So the Indian side is steeper as compared to the other side of the Himalayas. So you see this southern side of the Himalayas is much more steeper than the northern side of the Himalayas. So that means their folding mechanism is somewhat different. Then what will be the monoclinal fold, isoclinal fold, recumbent fold, overturned fold are all examples of a asymmetrical fold. For example, if I ask you, will there be the presence of nappes in the Himalayas? Himalayan mountain system are the result of extreme bending process, very complex bending process, very complex folding processes. So there will be the presence of nappes in the Himalayas. Nappes will be commonly seen in most of the mountains, including the Himalayas. That is the broken fold. After nappe, what will happen? If still further process, after breaking of this fold, suppose this is a nappe, it has broken down. If there is a further compressive force, then again it will keep on bending. And this bending will keep on happening till the time a mountain system is formed, till the time the horizontal endogenetic movement is stopped, or till the time the movement of a plate is stopped. So maybe a flat axis of the earth, it is bended initially into simple folds, then the kind of a fold increases, it is then become overturned fold, then it becomes nappe. Again this keeps on bending, resulting into formation of a very, very complex mountain systems on the earth. So what are the folds? Folds are wave-like bends formed on the earth's surface. So our next topic is faults. So faults. Now what are these faults and how they are different from the folding system? As the name suggests, what is folding? Folding is bending of any crustal parts, which we have now already studied in detail. Coming to the next part of the Earth's movement and the landforms. So why we are studying the faulting system? Because of the landforms, certain kind of landforms made by the faults. So the first topic is, what are the faults? What are the faults? That is the definition of a fault. What are these faults? Why does the earth fault? What are the types of the fault? What are the movements in this fault? and then what are the landforms which are formed by this different kind of faulting systems. So what are these different kind of landforms? What is a fault on the structure on the crust of the earth? In a simple terms, fault is a fracture on the earth's surface. What is it? It is a fracturing of the earth's surface. Now which part of your body gets fracture? The part of your body which will come under stress due to some conditions, maybe an accident, due to extra bending or due to extra pressure on some part of a body, that part will get fractured. Even in those parts, the part which is weak as compared to the other part, it has more chances of fracturing as compared to the stronger part. It's like with a stronger bone of legs are more stronger. They are more, the bones of the legs are more stronger, so the less chance of fracturing as compared to some kind of a tiny bone which is brittle. The same thing you can apply to the earth's surface. What are the faults? Faults are the fracture on the surface of the earth due to continuous pressure, due to continuous endogenetic force which is being put on the surface of the earth. So the definition of the faults are fracture in the crustal rocks. Which rocks? In the crustal rocks, not the entire surface of the earth. In the crustal rocks, due to, why? Because it is being subjected to extreme amount of force for a long period of time. It is caused due to endogenetic movements, or due to endogenetic force occurs at the surface it occurs at that part of the earth's crust which has been subjected to subjected to force, or which is under the force, which is influence of force for long period of time. That means any part of the earth's surface which is under the force for extremely long period of time will undergo faulting. So the fault is a fracture. You have to remember these keywords: fracture in the crustal rocks, due to which movements? Not exogenetic movements, due to endogenetic force, and it occurs on that part of the crust which is under the influence of a force for a very long period of time. Now, which part of the earth's crust will get fault? Fault is associated with weaker zones of the earth. As I told you, our bones which are weak have more chances of getting fractured as compared to the stronger bones. So the weaker rocks on the surface of the earth have more chances of faulting as compared to the stronger rocks. So the faults are associated with these are associated with weaker parts of the earth's crust, or they represent the weaker parts of the earth's crust. So the two important words you should remember is fracture associated with weaker parts of the earth's crust is fault. Now, what kind of Earth's crust will be subjected for faulting? Take an example of this too. Consider this too as an part of the Earth's crust. Now, what are the endogenetic forces? The endogenetic forces can be compressional forces or can be tensional forces. What is the difference between these two forces is that the Earth's crust can be subjected to pulling apart or it can be subjected to pushing this. If we compress the surface of the Earth, there are two kinds. If the elasticity of the rocks is very strong, if the rocks are strong, they will be subjected to folding rather than faulting, which we have already done in the last lecture, in the previous part of the lecture. But if the structure of the Earth or if the rocks there are weaker rocks, then they will be subjected to faulting. So, if this is a rock structure which has been subjected to or which has undergone a force, which has been subjected to force, any kind of a force, endogenetic or endogenetic force, any kind of a force by which I mean tensional force or compressional force. We will take an example of now tensional force. What is a tensional force? Tensional force is the force which is pulling apart, acting in an opposite direction. You pull a rubber band, it's a tensional force. Now take an example again of a rubber band. You pull a rubber band, it will get stretched up to a maximum limit. What is that limit? Elasticity limit. Once it cannot be stretched up to once it crosses its elastic limit, then the rubber band breaks in between. Same thing applies to the fault. The structure of the Earth, the crust of the Earth is pulled by the different forces. What are the forces? We have already, how it is pulled, we have already learned the theories. So it is pulled up to a maximum limit, and once that limit breaks, there is a fracture. So as a result, a fracture occurs on the rock surface and the rock may be broken or the rock may be faulted. Now, once the faulting occurs, this is an area where the faulting occurs. Then after the faulting, there are two parts of the rock. One is this part which has been faulted, while the other is this part which has been faulted. Now, once the faulting occurs, it may happen that rock will be displaced or rock will be moved along this line. So along this plane is known as fault plane. So faulting is the fracture of the rocks and the consequent displacement of a rock along a plane known as a fault plane. Now displacement means moving of the rock structure. The rock can move. Imagine this as a rock. If the rock can move along the vertical plane or along the horizontal plane, that it can move upwards, it can move downwards vertically, or it can move horizontally. So the fault is a fracture in the crustal rocks of the Earth, and the movement of these fractured rocks occurs along a plane known as fault plane. Now, how will be this fault plane? This fault plane can be vertical as well as horizontal. So, the movement will occur either horizontally or vertically along a plane which is known as a fault plane. And so fractured movement, and which are this part? These are the parts of the Earth which have undergone stress for longer period of time, hence the rocks have become weak and hence there is a fracture. Now what are the types of the fault? The types of the fault will depend on what kind of a movement is there, what kind of a force, or what is the direction of a fault. So based on this, there are we will be studying three different types of a fault. For our syllabus, they are normal faults, they are reverse faults, and they are strike faults. So these are the three different types of a fault. Now let me explain you each and every fault in detail. First, coming to the normal fault. Now this normal fault is a fault. You imagine again a rubber band. You are pulling a rubber band. You are pulling it away, and till the time its elasticity is reached, it gets pulled, and after that it is broken, and the rocks get, or the rubber band is broken into two pieces, and this rubber band gets displaced. That means one piece comes in your one hand, while the other piece will come in your other hand. The same thing you apply to the rocks. That is, till the time the rocks will be subjected to pulling force. When you say pulling force, means the rocks will be pulled in different direction. The rocks, if this is a fractured zone of the earth, you imagine that the rocks will be pulled in different direction. I am not pushing it, I am pulling it, and therefore this black color rock is, imagine this as a black color rock, it is coming down because it is subjected to pulling force. The crust of the earth gets elongated and the rocks get displaced along a plane which is known as the fault plane. Now to show you in the diagram, it will look somewhat like this. Now suppose this is a rock structure. It has not undergone faulting initially. Afterwards it gets faulted along a plane which is known as fault plane. After getting faulted along a plane, if it is subjected to the tensional force, what is a tensional force? It is a pulling force. When the two forces act in an opposite direction, if it is subjected to the tensional force, the rock, this same rock structure will get elongated. It will look somewhat like this. That is, this part of the rock gets moved downwards, it is pulled into opposite direction. So it is, the normal fault is a fault which is due to the tensional force, due to the pulling up of the rocks, and if you are pulling anything, obviously the thing is going to get elongated. So the normal fault results into the elongation of Earth's crust. So what is a normal fault? Normal fault is a fault which is formed due to one tensional force which pulls the rocks in opposite direction, resulting into the elongation of the crust. Now because the rocks is pulled in opposite direction, there is a displacement of the rock downwards. That is, if I am pulling this too, imagine this as a pulling force is being applied to this, it is getting displaced in a downward direction. So what is a normal fault? Due to tensional force, it is due to the tensional force when there is a displacement of the rocks in opposite direction. Displacement of rocks in opposite direction. normal faults result in elongation of Earth's crust. Normal faults results into elongation of Earth's crust. Can draw this diagram for it. Or if you want to draw a simple diagram in the examination, you can show it this way. So are you getting from this diagram that this was initial rock structure which got faulted along a plane, this fault plane, and in the second way, the rock got displaced, that is this rock moved downwards along a plane which is known as fault plane. So there is a downward displacement of a rock, there is an elongation with, if this is the size of the original earth crust, then there is an elongation of the size of the earth crust. So what are the normal faults? These are due to tensional forces. Look at the direction of the arrows. Look, the arrows are pointing away from each other in opposite direction. What does it denote? It denotes, be very careful when you draw these diagrams. The diagrams may look similar, especially in 2D or 3D. That is, but be sure about the direction of the arrows. So the pulling away of the rocks away from each other due to the tensional forces results into normal faults. There is a displacement of the rocks in opposite direction. Because of the displacement of the rocks in opposite direction, there is a fault which is generated, which is known as a normal fault. Okay. So you see there is a downward displacement of a rock. It results into elongation of the Earth's crust. Now coming to other kind, now before I go to other kind of a fault, if a person is standing here and if it looks downwards, what will it look like? It will look like a valley. For a person who is standing here, if they look upwards, it will look like a steep mountain or a cliff. So the faults result into kind of a landforms which are known as valleys, and mountains, they are known as block mountains and rift valleys. We will come to it again while dealing it as a separate topic. So before this, what is a fault? A fracture. Different types of a fault. First fault we did was a normal fault due to the tensional force, due to the displacement of a rocks in opposite direction. Normal faults result into the elongation of the Earth's crust. Now, the other kind of a fault which is known as a reverse fault. reverse fault, again taking an example of these two structures, instead of pulling away, if I push these two structures, it will result into this structure sliding upwards. So instead of pulling away, if I push these two structures, there is a compressional force being generated. So I am not pulling this, look, I am pushing them, and this, there is a sliding of this rock or remote over this blackboard duster or whiteboard duster. So you consider these two as a rocks, these are coming together, there is a fracture along this because of too much tension, and then slightly this remote slides over the duster, resulting into this remote going over the duster. Same will apply to the rocks also. The kind of a fault which is formed due to the compressional forces, which results into shortening up of the earth crust, and both the forces act in the same direction, is known as a reverse fault. So what is a reverse fault? It results in due to compressional forces What are these compressional forces? When there is a displacement of the rocks towards each other, results into displacement of the rocks towards each other. What does it result? It results into shortening of Earth's crust. It results into the shortening of the Earth's crust. So remember, the keywords here are shortening of the Earth's crust towards each other. Why towards each other? Because the force is a compressional force. How can you show it in the diagram? I'll give you both the diagrams. See. Now consider again our original diagram, in which there was a fault plane like this. Now instead of tensional forces, look at the direction of the arrows. The arrow direction is pointing this way. That means towards each other. Due to compressional forces, there is a displacement of the rocks in the same direction, resulting into this block riding over the other block. So it will result into So it will result into shortening up of the Earth's crust. An example of a compressional fault. So pushed it, it got compressed. Again, for a person who is standing here, and if you look downward, it will look like a valley. For a person who is standing here, and if you look upwards, it will look like a mountain. So the fault, again reverse fault, will result into the formation of a block mountain or a rift valley. Now the third kind of a fault is a fault is known as, the third kind of a fault is known as strike slip fault. Now what happened in both the fault we studied? In the compressional fault, that is the river fault, there was a displacement of the rocks towards each other and one rock went above the other rock. That is, there is a vertical movement. This is a vertical movement. In the normal fault, the rocks are pulled away from each other and as a result the rock moves away from each other, resulting into elongation of a crust, again a vertical movement. But there are some kind of a fault in which there is no vertical movement, just an horizontal movement. That is, the rocks do not go up or down, but the rocks just slide past each other. So we can show it this way. If these are the two rocks, they will just slide past each other on a plane, on a flat plane. Such kind of a fault in which there is only horizontal displacement of a rock is known as strike slip fault. Same thing as we studied in the plate tectonics as transform plate boundary or transform fault or conservative plate margin. So what is a strike slip fault? It is a fault in which the displacement of the rocks occurs in horizontal direction. Occurs in horizontal direction. Or occurs along the horizontal direction. For example, again, our diagram. If this is an original rock structure, it will be displaced horizontally if the fault is somewhat like this on the up. So there is just an horizontal displacement of a rocks. So this block is moving in one direction while this block is moving in other direction. So kind of a structure in which there is just an horizontal displacement of the rocks is known as strike slip fault. You can even show it by drawing a simple diagram such as this kind of a diagram. So what is a strike slip fault? Strike slip fault is an example when there is just an horizontal displacement of the rock structure. Now again, revising all the three kind of a fault. What is a fault? Fault is a fracture in the weak crustal rocks of the earth. So what are the fault? It is a fracturing of weak crustal rocks of the earth. Faults are classified into three types: reverse faults, normal faults, and strike slip faults. The reverse faults are formed due to tensional force. These are formed due to tensional forces. How is the displacement? Displacement is in the opposite direction. What effect it has on the crust? It results into elongation of Earth's crust. What is a reverse fault? Reverse fault is due to compressional forces. What is compression? In which there is a displacement in the same direction or towards each other. Towards each other. And what does it result? It results into shortening of the Earth's crust. What is a strike slip fault? When there is a displacement along horizontal fault plane. So, a diagram for each of them. Reverse fault. Normal fault. And strike slip fault is this can be diagram. So these are the important points you should remain in the faulting. Now what are the different kind of landforms which are made by the faulting? Faulting results into the formation of landforms known as Rift Valley and Graben, or Block Mountain and Horst. See, the faulting results into two kinds of landforms. These landforms are known as Rift Valley and Block Mountains. As I showed you here, whatever be the displacement of a rock. Now, if this is a normal fault, this is a normal rock structure, if there is a displacement of a rock towards each other or even away from each other, and if this is a person who is standing on the rock, if the displacement occurs in whatever manner, it will result into one rock moving up while the other rock sliding down. So for the person who is standing up, it will look down this elongated valley which is surrounded by the mountains from both the sides will look like an valley. So it is known as Rift Valley. So what is a Rift Valley? Rift Valley is a long and narrow depression. It is long and narrow trough-like feature or a depression formed due to faulting. It is also known as Graben, which is the German word for Rift Valley. It is also known as Graben, which is a German word for Rift Valley. On the other hand, what is a block mountain? Block mountain is upthrown or upthrust part is known as block mountain. It is the upthrusted part is known as a block mountain. In German word, it is also known as Horst. So what are the two kind of landforms? It results into the formation of a rift valley, which is long and narrow trough like a depression, or it results into upthrusted part, which is known as block mountain. So again, taking an example, if you are to be very clear, if you are standing here, on another hand, if a person is standing here, they are all both at the same plane. Now, if suppose this undergoes faulting, then this will be displaced upwards. It will result into this. For the person who is standing on the black part, the downward part will look like an valley. This is long and narrow depression, is known as a rift valley or a Graben, which is a German word. While the person who is standing on this part, the duster part, the yellowish part, if we look upwards, it will look like a mountain. Such kind of a mountain is known as a block mountain. So we have studied two kind of mountains. One is block mountain, which we have just studied, that is due to the faulting process, while one type of mountain which we have studied due to the folding process is fold mountain. The highest mountain systems in the world are fold mountain, because there is an extensive folding, while there are the mountains which are formed due to faulting are known as a block mountain. To give you a diagram of a block mountain and rift valley will look like this. So this is an example of a block mountain. These two parts are block mountain, or they are known as Horst, while the down thrown part is an example of an rift valley. So this is an example of a rift valley, and even this is an example of a rift valley. So the landforms which are made by the faulting are block mountains and rift valley. Any examples of a block mountain and rift valley in the world and in India? Yes, you should know these examples in detail. There are if you open your atlas and look at the map of Europe, you will see one of the major river system in Europe is river Rhine. So the river Rhine is the best example of one of the most well studied rift valley, because this river flows through a rift valley which is formed due to Vosges mountain, and on other side there is a Black Forest mountains. If you look at a country here, it is France, it is Germany, and down there is a Switzerland. So, upper Rhine Rift Valley, one of the best example is Rhine Rift Valley in Europe is one of the best examples of Rift Valley. Between Black Forest and Vosges mountain system of Europe, that is the river Rhine flows through a rift valley which is one of the most studied rift valley. Rhine Rift Valley between Black Forest and Vosges mountain system is one of the perfect examples of a rift valley. The second example, once you finish drawing, remember the country and the mountains also which they are situated. The second example of a rift valley is the African Rift Valley. On eastern part of Africa, it is also known as East African Rift Valley. So the East African Rift Valley is the second example of a rift valley, one of the rift valley in the world. It is the longest rift valley which stretches for a distance of The second example is East African Rift Valley. Now open your atlas and look at the map of Africa. You will see on the eastern part of the Africa there are some kind of the lakes and some kind of even dots are shown in some of the atlases. That is the perfect example of an East African Rift Valley. It is the longest rift valley in the world, starting from River Jordan, which goes into the Dead Sea region, then Red Sea region, then comes to Africa and flows through the Zambezi River basin. There are numerous lakes which are located in this Rift Valley region. Now suppose if there is a faulting which occurs, now if this is a rock structure, why there are numerous lakes associated in the Rift Valley region? Now before faulting, you imagine that this was a rock structure and on the lower part of the rocks there was a presence of a groundwater. Now suppose only this central part of the rock got submerged downwards, resulting into the formation of an rift valley. Then it will result into the central part going down then this groundwater will come up, resulting into the formation of lakes in this region. This is what is happening in the African Rift Valley region. So here the groundwater comes up, resulting into formation of a Great African Rift Valley. The place where the groundwater is fresh results into the formation of a freshwater lakes, while the place when there is a groundwater is saline, it results into the formation of saline water lakes. And the best example of a saline water lake is the Dead Sea region. So what is the Great African Rift Valley? The Great African Rift Valley is the longest rift valley in the world. It is the longest rift valley in the world. It stretches from River Jordan. Which are the two countries bordering here? Look into the atlas. What are the two countries? One is Israel and another is? Please look into the atlas. This is your assignment. You write down in your notes what are the two countries in this region. It goes from River Jordan to the Dead Sea region. Through the, what is the name of a sea here? Red Sea region. And through a river Zambezi Valley region. Through a Zambezi Valley region. So it is the longest rift valley in the world, which stretches from Dead Sea, Red Sea, through river Zambezi Valley region for a distance of more than 4,800 kilometers. There are numerous lakes which are associated with the Rift Valley of Africa. Now you have one more assignment, is what are the various kinds of a lake which are associated with the Rift Valley. You find it from north to south and from the north to south. There is what is the biggest lake in Africa? Which is the biggest lake? You will find out here that there is a lake which is known as Lake Victoria. Remember that Lake Victoria, is a lake which is not an example of a Rift Valley lake. That is, the Lake Victoria of Africa is not an example of a Rift Valley, while there are many lakes here which are present in the Rift Valley region, except for Lake Victoria. So the shape of the lake, which is somewhat round, circular, itself shows that it is not a Rift Valley, because generally the lakes which are associated with the Rift Valley are elongated, because the kind of a faulting is elongated. So Lake Victoria, it is surrounded by 3 countries, is not an example of an lake of a Rift Valley. Dead Sea, which is one of the most saline parts on the earth, is an example of a Dead Sea. It is between 2 countries, which is your assignment. We will come to it while again doing I am leaving it on you for a while. I am leaving it on you so that you will study the atlas, but we will come to this topic again while doing the world geography. So what are the lakes which are associated with the Rift Valley, not associated with the Rift Valley while studying the African continent, while studying West Asia? So you have to remember some of the facts, that the East African Rift Valley is the longest rift valley in the world for a distance of 4,800 kilometers. It starts from River Jordan, which drains into the Dead Sea. Remember that River Jordan drains into the Dead Sea region, then it passes through the Red Sea, then through Zambezi Valley up to the Africa. What will be the future of Africa? The future is that Africa will break away, this part of the Africa will break away from the mainland Africa, just similar to that Madagascar, which was once part of Africa. Due to rifting, it has broken away from the mainland Africa. Why are the lakes found, or why is the water found? Because the displacement or downward displacement occurs up to such a depth that the groundwater is exposed, resulting into formation of an rift valley lakes. This initial level of a groundwater, now due to the downward displacement, the groundwater is getting exposed, resulting into the formation of an rift valley lakes. So, this is the second example. The third example of a rift valley is recently there was a movie known as 123 or 124 hours, exactly I don't remember the name. Where was it shot? It was shot in one of the driest and one of the deadliest region, one of the region of USA. So, this is another example of a rift valley. The Death Valley of California. Why it is the name of Death Valley? Because there is so much heat and there is so much aridity in that region. Because of the downward faulting, a canyon has been formed. A deep downward faulting has resulted into a very, very deep valley, so that nothing can survive due to extreme heat here, and it is known as Death Valley in this region. So it is an example of, the third example is Death Valley of California. Third example is Death Valley of California. The fourth example of a rift valley is, we will take some Indian examples now. Are there rift valleys in India? Now, if you look at a map of India, we generally draw a map of India. I am not drawing a full-scale map now. So, in the map of India, we see that there is a Himalaya mountain system here. But there are two more mountain systems in this part. It is known as Vindhyan mountain system, and the lower part is known as Satpura mountain system. So, between these Vindhyas and Satpuras, there is a river which flows. What is the name of a river which flows between the Vindhyas and the Satpuras? It is river Narmada, which drains into the Gulf of Khambat or Gulf of Cambay region. So, in India, the best example of a rift valley is the river Narmada Rift Valley, which flows between Vindhyas and Satpura mountain ranges. So, the Narmada Rift Valley between Vindhyas and the Satpura mountain ranges is one of the best examples of a rift valley in India. The other example of a rift valley in India is river Tapi, which again drains into the Gulf of Khambat region. So in India, examples of a rift valley is Narmada Rift Valley region, second is Tapi Rift Valley region, third region is Damodar river also flows through a rift valley, and the Son river also flows through a rift valley. Third is the Damodar river region. And the last is Upper Son region. What do you mean Upper Son? only the upper stretch of a river Son has a rift valley. So the upper Son region. So these all are, we will again come to it while doing Indian geography. These are just the examples you should remember for the preliminary point of view. What are the examples of Rift Valley in India? One is the Narmada Rift Valley region. The second is the Tapi River region, Tapi Valley region. Third is the Damodar Rift Valley, and the fourth is the Upper Son region. Not the entire river Son, only the upper part or initial part of a Son river is an example of a rift valley. So there are 4 examples of rift valleys in India. So if the question comes other than these 4 rivers, which is an example of a rift valley river in India, there is no other example. These are the 4 rivers in India which flow through the rift valley. So these are the Indian examples. While we did the world examples, again they are, in India we have 4 examples of a rift valley. You have to remember, because the question generally comes from this: which of the following rivers flow through the rift valley? While at the world level we have the following examples: Rhine Rift Valley region, in Europe. Second is East African Rift Valley region. Which stretches from Jordan River, Jordan in Asia till end of Africa. It is the longest rift valley. And third is Death Valley of California. Remember that East African Rift Valley has a Dead Sea is a part of an East African Rift Valley. Dead Sea, West Asia, Death Valley, California. So this are as an example. Why it is known as Dead Sea? Because the salinity is so high that the animals or organisms or life cannot survive in the Dead Sea region. Why the Death Valley? Because it is so deep that the temperature is so high that it is very impossible for a life to survive in that region. So what are the rift valleys? What are the faulting? Faulting is the fracturing of the earth's crust, while folding is the bending of the earth crust. What is the difference? Folding results into very, very high mountain which are known as fold mountains, while the faulting results into the displacement. If the displacement is in the opposite direction, it is known as a reverse fault. If the displacement is towards each other, if the displacement is in the opposite direction of the rocks, get displaced in the opposite direction, it is known as a normal fault due to the tensional force. If the displacement is towards each other, that is compressional force, it is known as reverse fault. This both normal and a reverse fault will result into the formation of a rift valley, which is the long narrow depression like a structure. Can you see why long and narrow? Because between the two regions, Vindhyas and Satpuras, long narrow depression like a structure known as a rift valley or Graben, which is a German word. Why German word? Because the best studied rift valley in the world is Rhine Rift Valley, which lies mostly in the Germany region. So it is a German word. It's the Rift Valley or Graben. While the down thrusted structure is known as rift valley, while the up thrusted structure is known as a mountain, or what kind of a mountain? Block mountain. So faulting results into block mountain and rift valley. So this block mountains, again a German word for a block mountain is Horst. Or Horst. What are the examples in the world? Rhine Rift Valley is one of the best example of a very, very well-defined rift valley between Vosges mountain and between the Black Forest mountain. You can look at the diagram. We have drawn it earlier. East African Rift Valley is longest rift valley in the world, which rises in Asia from River Jordan, passes through the Dead Sea region, then goes through the Red Sea region. Red Sea is an area between Africa and between the West Asia. Then it comes to Africa and it passes through the eastern part of Africa. The point where there is the downward displacement and has occurred up to a greater depth, the groundwater has been exposed and it has resulted into the formation of lakes, which are known as a Rift Valley lakes. I have given you an assignment, jot down the Rift Valley lakes from north to south, otherwise wait for the World Geography lecture. Then, one of the largest lakes of Africa, that is the Lake Victoria, is not an example, you remember, of a Rift Valley lake. The Death Valley of California is again an example of a rifting. In India, we have the very best example of a rift valley is River Narmada Valley, which flows between two block mountains, that is Vindhyas and Satpuras. Then we have the Tapi Rift Valley region. Then we have Damodar Rift Valley region and some part of River Son, that is the upper course of River Son. These are the four examples of a rift valley. So this explains the endogenetic and exogenetic movements of the earth, that is the orogenetic movement, which results into folding and faulting. Why they are known as orogenetic movements? Because they result into formation of a mountains. What kind of a mountains? Folding results into the formation of a fold mountains. Himalayas, the loftiest, the mightiest mountain systems in the world. Rockies, Andes, Alps. Where are the Rockies? In North America. Andes in South America. Himalayas in Asia. Alpine mountain of Europe. These all are examples of a fold mountains due to coming together of two different plates. Due to coming together, collision and the bending up of the plates. On other hand, the other movement of orogenesis is faulting. Why it is known as orogenesis? Because again it results into the formation of a mountain. What kind of a mountain? Block mountain. Why the name block? Because you see the kind of a flat structure. Over the period of time, this due to erosion, due to denudation, the shape of mountains will be changed, but they are flat land can be faulted up and down, resulting into formation of a block mountain. On the other hand, folded mountains. So these are the forces of orogenesis. So you do these forces very well. Now we'll start with the next topic, that is the volcanism and earthquakes.